masses, 5 kilogram and 9.5 kilogram, are being held in place on a frictionless surface on either end of a spring of spring constant 75 Newton per meter that is compressed 2 meters. What is the velocity of each mass once the spring is completely unloaded and allowed to restore to its equilibrium position? Here, two masses are compressing the spring. So the work is done on the spring, and that work is stored in the form of elastic potential energy in the spring. When the spring is unloaded, the masses will move in two different directions with two different velocities. Our aim is to find out the velocity of each mass when the spring is completely unloaded. Now let us see how to solve this problem. The data is written here. So initially the spring has elastic potential energy. We will calculate the elastic potential energy of the spring using the data. After calculating the elastic potential energy, as the spring is unloaded, the masses will move into different directions. No? So the masses will acquire the kinetic energy. So the energy here, the energy of the system is conserved, and the elastic potential energy gets converted into kinetic energy of these two blocks. Okay. Therefore, we already calculated the elastic potential energy of the spring. Now we will calculate the kinetic energy. While calculating the kinetic energy, we will find out the velocity because we know kinetic energy is equal to half mv square. Now let us write the energy equation. So initial energy is equal to final energy. So here the elastic potential energy is equal to kinetic energy of the blocks. Therefore, half kx square is equal to half m1 v1 square plus half m2 v2 square. Here in this system, the momentum is also conserved. Therefore, let us write the conservation of momentum equation. Initially, the blocks are at rest, and once the spring completely unloaded, the masses will move with the two different velocities. Therefore, initial momentum is equal to 0, and then the final momentum of each block is m1 v1 and m2 v2. Therefore, initial momentum is equal to final momentum. Initial momentum is 0, and then final momentum is m1 v1 plus m2 v2. From this, we can make out m1 v1 is equal to negative m2 v2, and then solving for v1, we will get v1 is equal to negative 1.9 v2. Okay, now plug in the value of v1 in this equation, energy equation, and then solve for v1 and v2. Now from this, we will get v2 is equal to 3.3 meters per second. And then plugging in that value here, we will get v1 is equal to negative 6.27 meters per second. Okay, so this is the answer for this numerical. Hope this helps. Thank you. Bye-bye.